Howdy everyone, this is Jeff from the Ozark Mountains in Missouri, USA. Today we're going to be looking at programming the Commodore 64 using the Forth programming language. We'll split this up into at least two segments. The first will cover a brief history of Forth, some Forth basics, and setting up DurexForth for the Commodore 64. In part 2 we'll delve more into the nitty-gritty of it and look at how Forth compares to BASIC on the C64. Let me preface this next segment by saying if I had a Jedi costume, I would so be wearing it right now.
About now you might be thinking, hey Bert, so what is all this Forth language stuff about anyhow? Well, I'm glad you asked. Let's jump in and take a look at an instance of VICE running C64 BASIC and another instance running Forth. In both we can type in a simple expression like print 1 plus 2 and BASIC will tell us 3. In Forth, well, it's a little special. To do the same thing in Forth, we would type in 1, 2, plus, and dot. And it gives us the answer 3. You're probably saying, what the heck kind of system is that? Well, if you've ever used an RPN calculator, then this might look a little bit familiar. So let's find out a little bit more about this crazy way of entering expressions in Forth. Well, what it all boils down to is that the fix is in. That's right. This might be a little more than you ever wanted to know about different ways of writing out a mathematical expression, but stick with me, I thought it was kind of interesting. Starting from a young age, we are taught to write equations out algebraically, like this. 1 plus 2 equals 3. The operator, that is the plus sign, is in between the operands, or the numbers. The technical term for this is infix notation. Since this is how we learn to do math, it seems perfectly logical to us. The downside to infix notation is that we have to use parentheses and have rules for the order of precedence to know how to solve a problem. For example, 1 plus 2 times 3 is different than the quantity of 1 plus 2 times 3. This does not seem like a big bother for you and I, but the computer has to do a fair bit of work just to rearrange that equation into something it can handle. Before electronic calculators and computers were even a thing, a Polish chap named Jan Lukowicz, I hope I got that right, or close, invented a type of mathematical expression called Preface, which looks like plus 1, 2. This looks quite odd, but if you read this as add 1 and 2, it makes perfect sense, and it eliminated the need for parentheses. This became referred to as Polish notation. Postfix. When electronic calculators came around, the electronics of the day were not very powerful, and trying to deal with all the parentheses of an equation was difficult and expensive, given those constraints. The idea of writing the Polish notation the other way around, in other words 1, 2, plus, seemed like a good idea. It still does away with the need for parentheses, and it presents the data in the order the computer needs it. HP coined the term reverse Polish notation as a way to market this idea. Languages like BASIC use an infix notation. For example, you enter an equation like you would write it out on paper. The standard order of operator precedence is obeyed. In this equation, we would do 5 times 2 equals 10, and then add 4 to 10 to get 14. If, on the other hand, we were to put parentheses around that 4 plus 5 and make that quantity 4 plus 5, or 9 times 2, that would be 18. So depending on how we arrange the equation and the parentheses and the order everything's written in, it changes our outcome. For the computer, this makes evaluating infix much harder. With forth, you give it the operands, that is, the numbers first, and then the operator so it knows what to do with those numbers. For example, the equation we just used, x equals the quantity of 4 plus 5 times 2, in forth we would enter that as 4, 5, plus 2 times. Now that looks really odd till you learn how to read it. What this would do when forth evaluated this expression, it would push the 4 and 5 to the stack, which is kind of like a temporary storage area. Then it comes across that plus operator. And the plus operator knows that it needs 2 numbers to work with, so it pops the first 2 numbers off the stack, which is our 4 and 5. It adds them. It pushes the sum, the 9, back to the stack. Then it comes across to 2, it pushes the 2 to the stack, and then it comes across the multiplication symbol. Well, the multiplication knows that it needs 2 numbers to operate on as well, so it pulls that 9 and 2 off the stack and pushes the 18 back. That is much more complicated to explain and try to write out in English than it is actually for the computer to do. All of this stack manipulation is done by other languages like BASIC and C in the background. In forth, it is under our control. This lets us have the advantage of a higher level language which runs very quickly, but the downside is we have to be mindful of what we're doing to the stack. The stack. In forth, the stack is a last in, first out arrangement. Think of it like a narrow hallway with only one way in or out. All values in the stack are in a single file line. The last value pushed into the hallway, our stack, is the first one removed. I'm sure you'll read that forth is a stack-based language. What they're referring to is the programmer directly manipulating the stack. Now, this takes a little getting used to. It's completely different than BASIC or C or most anything else you've worked with. It's a little closer to assembly language. So if you've done a little assembly programming, some of the concepts will seem kind of familiar. And like I said, if you've worked with an RPN calculator, then it'll look a bit familiar too. I did some searching on the internet and found there were a number of implementations of forth for the C64 back in the day. Then I found an open source forth implementation on GitHub called DurexForth. This is the version of forth we saw earlier. What is DurexForth? DurexForth is a modern forth implementation for the C64. It complies with the latest Forth 2012 core standards. It includes a nice code editor, which is a VI clone, which itself is written in forth. It also includes a high-resolution graphics library plus MML music support. Coming up, we'll go over where and how to download and use DurexForth, including building DurexForth from source. What exactly is needed to build DurexForth from source? Well, we need a few things like Cygwin, ACME Cross-Assembler, and of course the DurexForth source. All of these are free. There's a few optional and free programs that make things easier too, and we'll cover that in detail coming right up. What I did was created a temporary folder where I downloaded all the files that I need to build DurexForth from source. I also created a development folder, which is at a path like this right under my documents, and the reason for that is it gives you a path without any spaces, which is a problem for some programs, and it's not in the root directory of the C drive, which is a problem for some builds. Like my work laptop really complains if you try to do that, and it's just a pain. So this gives you a nice, safe, and easy place to put everything. Now in Windows, particularly Windows 10, when you download something, tip is to right click on it, select Properties, and look out for this where it says Security. Tells you this file is blocked. Click on Unblock. Do that before you unzip that folder, or else every file inside will still be blocked and you'll have weird problems and not know why. And we'll check all of these. Sometimes things don't get blocked like that, and sometimes they do, so it's a good thing to check. So now we're up to the star of the show, which is DurexForth. There's a couple different ways you can get this downloaded. If you don't want to go the route of grabbing the source code, either the zip file or the Git repository, if you click on the releases right here and scroll down, you can download just the PDF, the source code zip right there, or a tarball of it, a cartridge file if you want to run it from a cartridge, or the D64, which you can open up in WinVICE. This isn't quite as up to date as building it from source. There's a few things that the author has added in the last few months which I think are very helpful. So you can do it this way. I'll show you how to build it from source as well. The most direct way, perhaps, is you can use the clone or download button here, and you can download a zip file, which is pretty straightforward, and that gets you the whole source tree here. Or if you have Git or SVN installed on your computer, this is the URL to where you can make a copy of the project, which is what I'll be doing. So I'm going to copy that to my clipboard, and I'll bring up the dev folder, and it's already popped our URL in there, which is nice. And this is the directory where it's going to save it, which is nice. We can click OK. And bada bing, bada boom, it's done. This way, if I want to upload some changes that I've made to the source, contribute to the project, I have an easier way to do that. Let's take a brief look at the web pages of the programs I mentioned previously. Here is Cygwin, and if you come to the main page and you're looking for the download, just look under installing, and that'll usually get you in the right direction. The next is ACME Cross Assembler. This is a SourceForge project. Usually they have a big green download button right here that'll get it for you. This is the WinVICE download page. This is the easiest place I found to get the correct version I need. This is the latest version here. I'm going between using this and this version right here. This is the Visual Studio extension for Forth. We'll get back to that in a bit. And this is the one for the ACME Cross Assembler. It's the extension for Visual Studio Code. We'll also get back to that in a bit. We'll go ahead and start out by getting Cygwin installed. Now once you download, that was it beeping, asking me if I really wanted to make changes. I said yes. What you download with Cygwin is the setup program, where it will go and download all the bits you need from some mirror on the internet. So we'll click yes here, and we'll say we want to install from the internet. And it asks us where we want to install it, and this is the dev folder we set up before. And it's going to create a local directory in the same directory by default where our Cygwin setup program is. So that's where it's going to place the files that it downloads for the installation. So we'll just go ahead and keep that there. Now it says, oh, it doesn't exist. Do you want me to create it? Yep, go ahead and create that. And we're going to use the standard settings there. Now, the first time I went to install Cygwin on this computer, it did not work right because the mirror I randomly selected did not have all the bits included with their standard package. So I'm just going to go with the top one on the list here. And this is going to download kind of a directory of things. Okay, for some reason that shot it up into a big full screen. What we want to double check on under Devel here that we have okay. There we go. We'll set up Devel to install. And I don't know of anything else. And we just need the binaries. We don't need the source code there. We'll go with that. And it'll take a few minutes for all this to install. I want to do both of these things. Okay, now we've got ACME assembler unzipped, but if we look in here, what we notice, this isn't the type of application that gets installed. It just gets run. So go back to here, take a copy of that guy and go over to our dev folder that we set up before. And you can see this is where we've installed Cygwin. And we'll paste ACME in there. What do we have left? Oh yes, VS Code. Let's go ahead and run this guy. And I do want to go ahead and launch this. So now we want to add our extensions to Visual Studio Code. Now you can go in here and search for them. And for instance, if we search for Forth Carlino, this is the one that we had the link to before, so we can install it from here. And now we're there. Now we can also, if you look for it in the Microsoft Store, or if you go from a link, let me bring our page back up here. Here was the ACME cross-assembler page. So you can click on install from here, and it says, yes, we know. Yes, I meant to switch apps. Would you like to install it? Yes. So, and the reload, that just kind of restarts Visual Studio Code and makes that extension active. Okay, I've written up these instructions, and I'll make a PDF of this available for download. There'll be a link in the description below. So we've gone through this part already with our folder and installing the packages. Now we want to set up some environment variables, and you can think of an environment variable as just a shortcut to store a complicated path or some other bit of information, so you can refer to it by a name rather than some big convoluted string. So we'll set up an environment variable for Cygwin, ACME, Durex, and WinVICE, and this will just make things easier for us later. So I'm going to use RapidEE for that, and I'm going to set them up as user variables, not system variables, which means that they will work for me when I'm logged in, but other people might not want the same thing, so they can add what they want. So if we right-click here under the user variable section and click add variable, we're going to call this Cygwin, it's a string. Okay, now if you try to enter a path that's not a good path, you'll get something that looks like this. I've moved where WinVICE was and my environment variable is not up to date. So that's what we want to fix. There were a couple things I messed up when I first set up the environment variables for Vice and ACME. So for Vice, what we want to do is point to the main Vice folder, which is here for the version I'm using. And the same thing for ACME. We want to point to the folder so it can easily access any program within that folder. Now, the big advantage to this is if we change or upgrade versions, we don't have to change everything that might refer to that directory. We can just change where Durex is pointing and everything else will still work. Now we also want to add these items here to the path. And the path is just tells Windows or your operating system where to look when you type a file and you want to run it. It tells it where to look for those types of things. So if we go down here, there's a whole pile of things in our path. So we want to add a value. And these percent signs around the name just say find what we've entered for our environment variable for ACME and expand it out to the full path name. Okay, now we're going to save our changes. And all of that's done. Okie doke. What we're going to do is make a small change to the DurexForth make file. So I'm open the DurexForth folder here. Drag the make file over to our Visual Studio Code instance. And right up the top here, we're not going to worry about what all this is, but what we do want to do is add this to the top of the make file. All that does is tell make that we want to use GCC to compile the C++ code. As part of the build process, DurexForth builds a little helper program that it uses. So different people's environments in Cygwin might be set up differently and default to different things, so this just tells it what to do so you won't have any problems. And we'll save that, and that is done. Now that we have everything installed, I'm going to go ahead and open Cygwin. What I've done here to make this bigger so we can all see it is right-clicked up in the title bar there, select Options and Text, and here I can choose the font I want to use and the size. And if you click Save, that'll save that so it uses the same thing every time. Now we're going to change our directory to our Durex folder that we did before. The $sign here just expands the environment variable Durex to the actual path. There we go. And then we use make all, which will look at that make file that we altered previously, and it should build us. I expect we'll get a couple errors or some things about Git and whatnot, but that should be fine. Yeah, you saw the Git and SVN errors, which is perfectly fine, and it looks like it built everything. And if we open our dev folder now and look in DurexForth, we see that we now have our Durex D64, which is the program file itself as well as all the associated extras that get built with it. so we can load that into Vice and start using Durex. So the setup took a little bit to be able to build and get things set right, but building itself is pretty painless. To demonstrate using DurexForth, I'm going to use Vice on a Windows PC, and I'll just go to File, Auto Start, Disk Image, click on the Durex.d64 file that we just created, click Attach. That will load it and automatically run it, and now we are in the Forth environment. Getting familiar with manipulating the stack is very important. It is something that just takes a lot of trial and error. As you might remember, the stack is a special place in memory which Forth uses to pass along arguments to functions, called words in Forth, and to hold the result of calculations, etc. Think of it like a long, narrow hallway where your data is awaiting in a single file line. There's only one way into or out of the hallway. It's a last in, first out arrangement. The last value pushed onto the stack is the first value popped off. When you enter something, say 25, I'll press enter, the interpreter will recognize it as a number and place that value on the stack. If we want to peek at that, we can use the .s command, which displays the stack, in this case our 25 we just entered, and a 35. We can also pop a value off the stack with the dot command. That removes the value from the stack, and it's showing it to us. And if we peek at it again with .s, we can see only our 35 is left. Now if we enter another number, say 10, and we have another peek, we can see the two values are on the stack with the 10 being the last one. It's kind of the next one that'll be popped off. And if we enter a word such as plus, Forth recognizes that plus is a word. It'll call that word, and that word knows it needs to take the first two values off the stack, add them, and put the sum back on the stack. So we had 35 and 10 on the stack, and we can peek at what it returned, which is 45. There are a lot of Forth commands for manipulating the stack too. For example, let's enter our two numbers from above, 35 and 10, and have a peek at what's on the stack. So we have the result of our calculation and the two numbers we just entered. And if we type in swap, have another peek, you can see that it swapped the order of the last two items on the stack. There are words for duplicating items on the stack, dropping items from the stack, etc. These come about as you wind up quite often needing to rearrange the values, as they can be pushed onto the stack in a different order than what you wind up needing to use them. Getting used to stack manipulation and having a mental picture of what effect you're having on the stack is tricky. Well, at least it was for me. The book Starting Forth, which has the link in the description below, is a great place to start. I borrowed a second edition copy of the book from the university library, but found out there are many parts of it that are out of date. The online version linked below is a better reference for learning. I was trying to get some idea about how fast Forth was on the Commodore 64 compared to BASIC. I also wanted to do something visual, so I set about to fill the screen with the same character as quickly as possible. This involves some looping and calculating of the correct address to poke the character into for the full 1000 RAM locations that make up the screen memory. The simple program shown here does just that. It uses a for loop to go through all 1000 screen addresses, adds that to the base address of the screen, and pokes a 1 there, which is the A character. The time string set to 0 here, and the print time string just use the built-in Jiffy clock to time the program execution. So if we run this, you can get an idea of how slow this is in BASIC. And it's hard to see on the screen, but if we look up at this line right here, that shows that it took about 9 seconds to complete. Now let's look at this in Forth. I wrote the same program in Forth using Visual Studio Code as shown here on the right. Now you notice when this program starts out, it sets some constants, which is similar to other programming languages. There's an include. Now this is similar to including a library or other code in C or similar language. It's including the timer2 module, which accomplishes the same function as timestring does in BASIC. And then we get to the program proper. Now when you see a set of parentheses like this, that indicates that it's a comment. And this .283s will make sense shortly. So the name of our word is plot linear, and this particular comment right here with the 2 dashes is called a stack comment in Forth, and it indicates what's taken by this particular word on the stack and what's left on the stack. And this word takes nothing off the stack or leaves nothing on the stack, so there's nothing on either side of the dashes. Page just clears the screen. Start starts the timer, and then we see max SCR 0 do. This starts a loop that goes from 0 to max SCR, which if we look at our constants up here, that's in hexadecimal. That is the 1000th position on the screen. In here we're pushing a 1 onto the stack, which is our A character, and then we're taking the value of our screen constant, which is where the screen starts. The capital I is the index of our loop. And then the plus. So we saw the plus before. The plus is going to add the last 2 items on the stack, which in this case is our loop index and the screen starting address. And then we have this C exclamation point. What that's doing is saving an 8-bit value or a byte to an address, and the address is given by what we calculated right here, screen plus I, and what it's saving is the value 1. That seems terribly confusing because we're kind of reading left to right and doing things right to left, but after you stare at it a while it starts making more sense. And then loop tells it to go back and complete the loop. Stop stops the timer, and this dot quote just prints out this text. The CR is a carriage return. Now to get this into DurexForth is fairly easy. We're going to copy this, and then we're going to go over here, and if we just type VI, that'll take us into the editor. And then we want to press I to go into insert mode, and if you right click on the mouse, it'll type everything in there for us. We can tell we're in insert mode because of the I down here. Then on the PC keyboard, if you press the tilde key, which is the one just left of the 1, that'll take you out of insert mode, and then we can type :W exclamation point, which just means save as, and we'll save this as plot linear. And again with the tilde key. And now if we type F7, it should compile. The sparkling around the edges of the screen is just showing that it's pulling in timer2 and compiling all that. If there was any errors, it would show here that there were errors, but theoretically this should work now. So if we type in plot, linear, if I can spell, plot linear, you can see how much faster that was. And it took a whopping 0.283 seconds. So that's compared to 9 seconds on the basic version, which is quite an improvement. Now, if you're curious about this include timer 2, here it is. Now this is based on the timer code that's included with DurexForth, but I modified it to use all 3 bytes of the Jiffy timer because I needed a longer term timer for another benchmark I was porting over. This is actually some inline 6502 assembly code. which allows you to set the time of the Jiffy timer. And you can see here I tried to put comments in here so I had to remind myself what it was. This just takes all 3 bytes of the Jiffy timer and pops them onto the stack as doubles. And then this is the stop and prints the elapsed time using some forth formatting commands, which I still don't have a really good grasp on. But you probably may have noticed up here it requires math X'd up here, which is just some extra math routines I wrote. And the only ones that it's using for this are D+, which is a double addition, double subtraction functions. And I wrote some other things, a couple different square root functions, that type of thing, which aren't used for this demonstration.
I hope that this brief introduction to Forth has made you curious enough to download DurexForth or some other version of Forth and give it a try. I have found that it's nice being able to test out my code in WinVICE because, just like when learning machine code, you'll lock up a real C64 a lot. With Forth, though, you can type in most things one line at a time directly into the interpreter and try things out to see where your problem lies. I would like to do at least one more episode on Forth, covering debugging the things I've learned along the way to make it easier, etc. If you have any questions about Forth that you would like an answer to, please let me know. Forth is a very new language for me, but I'll do my best to find out an answer for you.